Roll number 3. को roll number 3?
Sir, roll number 4 लाई होला मलाई दिइसक्नु भयो.
Roll number 4.
रेशम भण्डारी हुन्, रेशम भण्डारी आइसकेछ.
Roll 5.
Yes, sir.
रेशम यो चाहिँ effect of rate of sowing on yield attributes and yield of wheat हैन in only include the research from नेपालबाट भएको रिसर्चलाई मात्रै इन्क्लुड गरेर असाइनमेन्ट गरौँ. ओके. ओके. वेट को मैले सेकेन्ड नम्बर दिन बाँकी थियो हैन. वेट को फर्स्ट को अरे.
हजुर सर.
मैले त तिमीलाई त दिए नि है.
हजुर सर.
सेकेन्ड रोल नम्बर वेट
सेकेन्ड किसा हो सर? उ जोइन भयो हैन, एकछिनमा हुन्छ होला.
3.
Yes, sir.
किसा नै आइपुग्यो. ओके. यो किसा त्यहाँ मैले च्याट बक्समा राखेको छु. इफेक्ट अफ रो स्पेसिङ अन विड डाइनामिक्स अफ डाइरेक्ट स्टेट प्राइस. Especially you can take an example of India, Nepal and Bangladesh. That means dry direct seeded TDSR. त्यसलाई वेट डाइरेक्ट सेडेड भन्न जाउँ. त्यसको चाहिँ वेट डाइनामिक्स भन्नाले के कुरा इन्क्लुड गर्नुपर्छ त भन्दा वेटको डाइभर्सिटी कस्तो छ एन्ड द वेटको ड्राई वेट एन्ड द वेटको पपुलेसन. All three are considered as the dynamics. Row spacing change in the whether there is the change in the number of weed species, whether there is the change in the weed population and the dry weight. के हुन्छ भन्ने कुरा. And also include the yield हैन. त्यसको yield मा पनि हेरौँ. त्यहाँ वेट डाइनामिक्स एन्ड yield भनेर थप्नु सर मैले yield भनेर बिर्सेछु. एन्ड yield भनेर चाहिँ त्यसमा थप्नु अफ ड्राई डाइरेक्ट सेडेड राइस है. ओके.
सर एकचोटि फेरि टपिक भनिदिनु न.
मैले च्याट बक्समा लेखेको छु नि. इफेक्ट अफ रो स्पेसिङ of row spacing on the weight dynamics and the grain yield of dry direct seeded rice.
Thank you, sir.
Dry direct seeded rice. So thank you on that topic. Weight dynamics भन्नाले वुडको population, वुडको डेन्सिटी भनेको पपुलेसन भइहाल्यो. एन्ड द्याट अफ द स्पेसिस, नम्बर अफ स्पेसिस द्याट इज रिलेटेड टु डाइभर्सिटी एन्ड ड्राई वेट. त्यसको बारेमा चाहिँ डिल गर्नु. ओके. म दिँदै जान्छु बिस्तारै हातलाई पनि है. जसलाई पहिला दिन्छु उनीहरूले पहिला चाहिँ प्रेजेन्टेसन पहिला गर्नुपर्छ हैन. स्टार्टिङ फ्रम द नेक्स्ट विक है. नेक्स्ट विकको एक हप्ता पछाडिबाट मनिलाबाट सुरु हुन्छ. ओके. हामी हिजो चाहिँ हिजो पनि आयो सँगसँगै नेट पनि डाउन भइहाल्यो. फ्याक्टर एफेक्टिङ द डिनाइट्रिफिकेसन फ्याक्टर के कुराले असर गर्छ डिनाइट्रिफिकेसनको निम्ति हैन. वान इज द अक्सिजन कन्सन्ट्रेसन. oxygen concentration that is related to the case of the formation of the oxidized zone को formation सँग चाहिँ असर गर्छ हैन. When the oxygen concentration on the oxidized zone is high, जति high हुन्छ there is a chance of the greater amount of the denitrification, and there may be the chance of more diffusion, and all amount of that nitrogen is lost through the denitrification. So that the oxygen level, that means it is very important for the case of the denitrification. Denitrification ma oxygen अथवा the especially the thickness of the oxidized zone is very important. Oxidized zone को thickness एकदमै important हुन्छ. मैले त्यो कुरा भन्दै थिएँ अनि मैले सोध्दै थिएँ alternate wetting and drying को केसमा. Have you heard about the alternate wetting and drying? Alternate wetting and drying को बारेमा सुनेछ कतै? मदन?
Yes, sir.
Alternate wetting and drying भनेको के होला?
सर त्यो पिरियडिक रूपमा खेतमा पानी हाल्ने अनि सुकाउने फेरि हाल्ने सुकाउने गरेर
that is alternate wetting and drying. Alternate wetting and drying को केस हो. अनि alternate wetting and drying को निम्ति one experiment हामीले अहिले चैते धानको निम्ति उडको continuous flooding गर्दा र alternate wetting and drying गर्दाखेरि उडमा कस्तो किसिमको असर हुन्छ and the drainage-मा कस्तो किसिमको असर हुन्छ भनेर अहिले स्प्रिङ राइसको निम्ति one experiment डिजाइन एउटा एक्सपेरिमेन्ट डिजाइन गरेर अहिले चाहिँ ज्योतिनगरमा चाहिँ हाम्रो के अरे शुभेच्छा रेग्मी सिनियर स्टुडेन्टले चाहिँ गरिराखेको स्थिति छ हैन. अल्टरनेट वेटिङ एन्ड ड्राइङ भनेको चाहिँ के हो? मदनले भनेको जस्तै भन्ने periodic drying and that of the waiting period of the soil को periodic drying and waiting period हो. त्यो भन्नुभन्दा पनि irrigate the field, हामीले फिल्डलाई चाहिँ के गर्छौँ भन्दा irrigate गर्छौँ, then let it to be dry, यसलाई चाहिँ हामी dry हुन जान्छौँ until there is no formation of the crack. formation चाहिँ crack को formation चाहिँ dry हुँदै जाँदाखेरि crack को formationहरु हुन सक्छ, त्यस्तो formationहरु हुन नदिने हैन. भन्न खोजेको crack formation भएपछि के हुन्छ भन्दाखेरि there is the more compact soil surface that formed and there is the low amount of the tillering or that may stress the that the false steam जुन बेलामा growing point के हुन सक्छ भन्दा ग्राउन्ड लेभलको तल हुन सक्छ, त्यस्तो बेलामा जुन माथि हामी देखिरहेका हुन्छौँ that is the false steam, not reality that is the steam that is only composed of the leaf seed. leaf seed composed भएको हो भने त्यस्तोलाई चाहिँ के गर्छ भन्दा कहिले कहिले ड्यामेज गर्न सक्छ र टिलरिङ पनि कम हुन्छ. त्यही भएर हामीले फेरि इरिगेट गर्छौँ कहिले भन्दाखेरि बिफोर देयर इज द क्र्याक फर्मेसन भन्दा जब चाहिँ सर्फेस लेयरको मोइस्चरहरू चाहिँ ड्राई हुँदै जान्छ र हामीले पडलिङ गरिसकेपछि फिल्ड के छ भन्दा एकदमै कम्प्याक्ट छ, त्यसपछि लस हुने भनेको त सर्फेस अथवा डिपर लेयरको मोइस्चर लस हुने हो. तर त्यसको डिपर लेयरको मोइस्चर लस गर्नको निम्ति एज कम्पेयर टु द ड्राई फिल्डमा चाहिँ क्यापिलरीहरू हुन्छ जसको कारणले गर्दा के हुँदैन भन्दाखेरि क्र्याक फर्मेसन हुँदैन. But in case of the puddle soil, there is no capillary. Around 91 to 100% of the micropores they are destroyed during the puddling. That means there is no capillary connection. Then how the soil of the deeper layer is dried that forms due to the formation of the crack formation. That's the scenario. In case of the field, how we measure or how we conduct the experiment regarding that of the alternate wetting and drying को एक्सपेरिमेन्टहरु हामी कसरी गर्छौं, हामी कति चाहिँ कसरी गर्छौं भन्नको निम्ति म एउटा चाहिँ यहाँ रिलेटिभ ब्लग गरेको एउटा भिडियो छ, म त्यहाँ शेयर गर्छु प्लिज.
Almost half of the world's population is depending on rice as their staple food. By 2020, fast becoming a precious commodity as more and more people use water for the household, industry, and agriculture. Rice uses up the most amount of water in agriculture, with almost half of the world's population depending on rice as their staple food. By 2025, 15 to 20 million hectares of irrigated rice fields may suffer from water scarcity. To address this problem, scientists have developed a technique called alternate wetting and drying, or AWD, which uses less water to grow rice. AWD is a water-saving technology that lowland rice farmers can apply to reduce water use in irrigated fields. In AWD, the rice field is allowed to dry for a number of days before being flooded again. Hence, the field is alternately flooded and left dry. The number of days that the field can be left dry depends on the soil type and other field conditions. A practical way of applying AWD is by observing the depth of water in the field using a field water tube. After irrigation, water level will gradually decrease. When the water level has dropped 15 centimeters below the soil surface, the field should be reflooded to a depth of 5 centimeters. Allowing the water in the field to drop 15 centimeters below the soil surface before irrigating again is called safe AWD. The 15 centimeter limit will not cause any yield decline, since the roots of the rice plants will be able to take up water from the saturated soil and the perched water level in the surface. The field water tube helps farmers see the hidden source of water. Safe AWD irrigation can be started a few days after transplanting or when the direct seeded rice crop is already 10 centimeters tall until first heading. When many weeds are present in the early stages of crop growth, safe AWD can be postponed for 2 to 3 weeks until the weeds have been suppressed by the ponded water. Local fertilizer recommendations for flooded rice can be used. Apply nitrogen fertilizer, preferably on the dry soil just before irrigation. A week before to a week after the peak of flowering, water should be kept at a 5 centimeter depth to avoid water stress, which could result in potentially severe yield loss. After flowering and during grain filling, apply safe AWD again. In safe AWD, water savings may be relatively small, about 15 to 25%, but there is no yield penalty. Once farmers are confident that safe AWD does not reduce yield, they can experiment by lowering the threshold level to 20, 25, 30 centimeter depth, or even deeper before irrigation. The field water tube can be made of a plastic pipe or bamboo or other indigenous materials that will help farmers see water below the soil. Cut this material to a 40 centimeter length with a diameter of 50 centimeters or more to easily see the water level inside the tube. The bottom 20 centimeter length of the tube should be drilled with holes on all sides. Holes should have a diameter of about 0.5 centimeter each and spaced about 2 centimeters away from one another. The tube can be placed on the side of the field close to the pond, but not less than a meter away for easier monitoring. Bury the tube vertically into the soil so that 20 centimeters or half of its length protrudes above the soil surface. Take care not to penetrate through the bottom of the plow pan or hard pan, which is a dense layer of soil that is largely resistant to water. Remove the soil inside the tube so that the bottom of the tube is visible. Check that the water level inside the tube is the same as that outside the tube. Alternate wetting and drying, or AWD, is already a mature technology that can be readily used by farmers. The field water tube is a very simple tool that guides farmers to effectively and efficiently manage their limited irrigation water for their rice crop. However, farmers can only truly appreciate the benefits and water savings from AWD if adoption of this promising technology is done at the community or system level.
Okay, it is about the AWD, alternate wetting and drying. Alternate wetting and drying, how we make a water tube, how we install the water tube in the field. That is the alternate wetting and drying, but we cannot do the experiment, especially in case of the summer season for our soil in Rampur. There is always बॉडिङ हामीले वर्ष चाहिँ गर्मी भनेर इन्स्टल पनि गऱ्यौँ वाटर ट्युब्सहरू, बट इट इज भेरी डिफिकल्ट, हामीले गर्न सकेनौँ पछि। भन्नु खोजेको when there is the alternate wetting and drying, alternate wetting and drying मा what the in case of the nitrification and denitrification, what scenario is preferred? In case of the drying period, there is the formation of nitrate from ammonia. That means there is a high chance of the nitrification. While immediately after the dry period, there is the flooding in the field मा flooding हुन्छ, जसको कारणले गर्दा there is again the denitrification favor. भन्न खोजेको in the scenario of alternate wetting and drying, maximum amount of fertilizer is lost through the denitrification. Denitrification बाट loss हुन्छ. It is the one disadvantage of the alternate wetting and drying. It is related to the oxygen concentration, especially for in case of the surface soil during the dry period. I have already told about the alternate wetting and drying. Another is the factor affecting the denitrification, that is the one is the pH and another is the electrical conductivity. The stable pH value of the flooded soil generally high conducive for the denitrification, because most of the soil microbes mediating the denitrification seems to be function near the pH 7. There is also microbes जुन चाहिँ nitrification अथवा denitrification गर्ने छन्, तिनीहरू नर्मल्ली 7 pH अथवा न्यूट्रल pH मा के हुन्छ भन्दा मोर इफेक्टिभ हुन्छ। त्यही भएर pH 7 हो which is created by, मैले भनिहाले, हामी भोलि पढ्छौँ त्यसको बारेमा, how the pH 7 is maintained, how the neutral soil is maintained when we planted the rice in the either acidic or alkaline soil. But in case of the neutral pH, there is a high activity, more activity of the microbes. Microbes are body activity हुन्छ, जसको कारणले गर्दा there is more amount of the nitrogen loss through the denitrification. Another is the soil temperature. Denitrification rate in the anaerobic incubated rice field varied with the soil type and increase markedly as the temperature goes from the 5 to 45 degrees Celsius, because the activity of microbes is increasing with increasing the soil temperature. Another is the level of the nitrate present. In case of the when the denitrification normally depend upon the amount of the nitrate or the concentration of the nitrate of the soil, or it depends upon the nitrification reaction. Denitrification कति हुन्छ भन्ने कुरा nitrification reaction मा चाहिँ के हुन्छ, that depend हुन्छ। त्यही भएर when the level of the nitrate is high in case of the soil, there is a high chance of nitrification of the flooded soil. Another is the organic matter content, because the denitrifying bacteria needs the organic matter content for the source of food for their nitrogen and the activity. The nature and the amount of organic matter in summer soil that largely determine the denitrification at a given temperature and the nitrate concentration. Water-soluble organic substances, the low molecular weight, have the greater effect on the denitrification than that of those materials which are low solubility and the high molecular weight. Little or no gaseous loss of nitrogen for the incubated waterlogged condition when the soil organic content is very low. Soil organic matter is एकदमै कम भयो भने के हुन्छ त भन्दाखेरि there is a low amount of the denitrification loss, because there is a low amount of the microbes present in the soil, because the organic matter that pump or that act as a food for the microbes. The loss of the nitrogen was greatest in the low oxygen content combined with the high level of the organic matter content in case of that is the organic matter content, especially when they incorporate the maize leaf, which is the green maize leaf of the spring season to the summer season maize. If the summer season rice crop, summer season rice crop लगाउने बेलामा हामी स्प्रिङ सिजनको मिक्स भएको मेज प्लान्टहरूलाई चाहिँ इन्कर्पोरेट गरिदिएको बेलामा र अक्सिजनको कन्सन्ट्रेसन कम हाई अमाउन्ट अफ द denitrification. Another is the activity of the denitrifier. In the early stage of the flooding, that nitrate disappears rapidly, with the increase in the denitrifier. Especially in case of the nitrification. Nitrification is occurred in case of the aerobic soil, and the denitrification occurs in case of the reduced soil. That means those bacteria which are responsible for the conversion of the ammonium to the nitrate, they are aerobic bacteria or aerobic in nature, while that of the which is responsible for that conversion of nitrate to the nitrite or the elemental nitrogen gases. Nitrogen is the anaerobic. Immediately after the flooding गर्ने बित्तिकै के हुन्छ भन्दा there is a low amount of the nitrifier. That means there is a high depth of the that के भन्दाखेरि reduced down को चाहिँ thickness चाहिँ बढी हुन्छ. When the water is that water चाहिँ जब जम्दै जान्छ stagnant हुँदै जान्छ, there is a progressive increase in the thickness of the oxidized zone. Oxidized zone को thickness चाहिँ बढ्न जान्छ. त्यही भएर immediately after the application of water or immediately after the flooding, there is a rapid increase in the denitrifier. There is no marked increase in the nitrifier in the aerobic layer. At the middle of the oxidized zone develop and consider the increase of the nitrifier in the surface layer. Denitrifier population is maintained at a high level, and the result of the nitrate did not accumulate. किन भन्दाखेरि denitrifier को population बढी हुन्छ because there is a more amount of the volume of the soil of the reduced zone. त्यही भएर nitrate चाहिँ पाउँदैन. At the later stage, number of the nitrifier are subsequently higher and the number of the denitrifier will drop. जति चाहिँ के हुँदै जान्छ, oxidized zone को thickness चाहिँ के हुन्छ भन्दाखेरि बढ्दै जान्छ. There is a reduce in the thickness of the that reduced zone with presumably due to the decrease in the substrate concentration as well. किन चाहिँ decrease हुन्छ त आफ्नो the food for the microbes with the organic matter is already consumed by the in the earlier period. Another is the submergence period. Nitrogen loss from the fertile soil due to the subsequent nitrification and denitrification will become significant to one after the 1 or 2 weeks of the flooding. यति बेलामा oxidized and reduced zone चाहिँ formation हुन पर्यो. This is about the what are the factors that influence the denitrification. Denitrification कुन factorले असर गर्छ भन्ने कुरा भयो. Another is the ammonia volatilization. How the ammonia volatilization occur, what are the factors responsible for it. Ammonia is the readily form of nitrogen mineralization in the absence of oxygen and continuously in water, soil and water of the flooded soil. Ammonia चाहिँ कुन बेलामा बन्छ त भन्दा when there is a continuous flooding. जब continuous flooding हुन्छ ammonium will not get a chance to convert it to nitrate मा convert chance त पाउँदैन धेरै. At that time the ammonia is released from the ammonium ion. The use of the nitrogen fertilizer in rice also contributes a large concentration of the dissolved that ammonium salt. That ammonium form of fertilizer may dissociate directly like a urea by the hydrolysis, especially by the urea enzyme to produce the ammonium ion in water, and the ammonium ion loosely bound in the water molecules predominating in water of the pH below 9.2. With increase in the hydroxyl ion concentration in the water, in case of the higher pH, that ionized NH4+ that increasingly convert to the non-ionized ammonia, which escape from the water as a gas. जति चाहिँ in case of the acidic soil, in case of the acidic soil or acidic concentration in the soil, त्यो बेलामा चाहिँ के हुँदैन भन्दा ammonia volatilization is not a common mechanism of loss, but this mechanism of loss is increasing. यसको mechanism of loss increases in case of the alkaline soil or alkaline nature. Ammonia soil, on a soil moderately and slightly acidic, although losses are the highest on alkaline soil. The water pH value increased by the midday as the pH of 9.5 to 10 and decreased as much of the 2 to 3 pH units during the nights. के हुन जान्छ भन्दाखेरि in case of the daytime मा चाहिँ वाटरको pH चाहिँ increase हुन्छ because that consume the carbon dioxide consume गर्छ in case of the daytime or by the aquatic weeds हरूले चाहिँ consume गर्छ especially चाहिँ जसरी विदाउट अक्सिजन चाहिँ भइराखेको हुन्छ त्यस्तै गरी कार्बन डाइअक्साइड इज अल्सो देयर इन केस अफ द विदाउट अक्सिजन which increase the pH चाहिँ increase गर्छ in the daytime. And in case of the night time, there is the release of the carbon dioxide as a part of the respiration को part release that form the carbonic acid and there is the decrease in the soil pH and decrease in the भन्न खोजेको मतलब in case of the daytime when the temperature is high त्यस्तो बेलामा चाहिँ के हुने भन्दा soilको pH up to 10 पुग्ने भएर substantial amount of the volatilization of nitrogenous fertilizer is occur. When the water pH rise above 7.4, ammonia volatilization losses may be appreciable. pH affect the equilibrium between the ammonium and the nitrate because the relative concentration of ammonium that increase from चाहिँ हामीले हालेको फर्टिलाइजर्स अथवा हामीले हालेको चाहिँ नाइट्रोजनस फर्टिलाइजर अथवा नाइट्रोजनको सोर्सको proportion of the mineral nitrogen को proportion के भनेको mineral nitrogen भनेको ammonium and nitrogen तिनीहरुको proportion हेर्नु त के छ भन्दाखेरि when the pH is tends to 6 to 7 6 बाट 7 मा जाँदाखेरि the relative concentration of ammonium is increased by 0.1%. 7 to 8 जाँदाखेरि that increase by ammonium concentration 6 to 7 मा जाँदा 1% ले 7 to 8 मा जाँदा 10% ले र 8 to 9 मा जाँदा 50% ले ammonium को concentration चाहिँ increase हुन्छ भन्न खोजेको मतलब in case of the high pH हुँदाखेरि why there is a high chance of the volatilization because there is a high proportion of the ammonium as compared to nitrate in the soil. Increasing the temperature increase the relative proportion of ammonia to nitrate at a given pH, decrease the solubility of ammonium in water and increase the diffusion of ammonium away from the air water and the air soil interface. Increasing the temperature जति increase हुन्छ there is a relative proportion of ammonium is increased at a given pH and decrease the solubility of the NH3 in water को NH3 solubility decrease हुन्छ जब solubility decrease हुन्छ what happen that is stable as a gas form मा चाहिँ stable हुन्छ. The susceptibility of the ammonium and the amide fertilizer to the ammonia volatilization, highest ammonia volatilization occur in case of the urea because that immediately after the hydrolysis, urea is dissolved the ammonium ion and that is higher proportion of the ammonia volatilization as compared to ammonium nitrate where there is the one molecule of ammonium and another is the arco molecule चाहिँ के छ भन्दाखेरि nitrate छ. And ammonium sulfate, there is, that is another case why the ammonium sulfate is why there is the less amount of the ammonia volatilization by the ammonium sulfate because it is due to by the application of ammonium sulfate or as compared to urea, ammonium sulfate is 1.5 times more acidic. And when we apply the ammonium sulfate, हामी जति ammonium sulfate apply गर्छौं त्यो बेलामा के हुन्छ त भन्दाखेरि soil को pH चाहिँ decrease गराउँछ because it is more acidic त्यही भएर ammonium sulfate बाट चाहिँ के हुन्छ भन्दा कम ammonia volatilization हुन्छ. युरिया त्यसको दुईटै मोलिक्युल ammonium बन्ने भयो ammonium nitrate मा एउटा मोलिक्युल ammonium छ एउटा मोलिक्युल nitrate छ obviously दुईटै ammonium बनेकोबाट चाहिँ ammonia volatilization बढी हुन्छ as compared to one nitrate and one ammonium ion and why it is low though the ammonium sulfate that form the ammonium ion बनाउँदै पनि किन लो हुन्छ त the ammonium sulfate that they increase the soil acidity because the ammonium sulfate is around 1.5 times more acidic than urea. Why it is 1.5 times more acidic than urea? यो कुरा म अर्को सेमेस्टरमा कसैले चाहिँ soil fertility को कोर्स लिएछ भने त्यसको बेलामा म पढाउँछु. And in case of the ammonia volatilization, you can observe त्यहाँ चाहिँ observe हामीले हेर्न सकिन्छ. हेर्नु त चाहिँ के भइराखेको छ, ammonium absorb जुन चाहिँ हामीले एप्लाई गरेको ammonium that is absorbed in soil first reaction is रियाक्सनलाई क्लियरफुल्ली हेरौँ. फर्स्टमा चाहिँ के हुन्छ भन्दा ammonium absorb हुन्छ, that is released into the soil solution. यो चाहिँ पानीमा आयो. Then that is changed into the ammonium in solution भनेको ammonium ion that is aqueous nature, हैन, aqueous nature in solution, and that is the aqueous nature in soil, and that is released to atmosphere. In case of the daytime, why that happen? I know why that case, especially in case of the photosynthesis and reproductive activity of the summer aquatic biota, where biomass factor affecting the growth play an important role in regulating the pH. In case of the daytime, that the carbon dioxide is used up, and there is the formation of the sugar. That process is alkaline process or basic process. While the opposite is occurred during the night time, the opposite reaction happen with release the carbon dioxide. That carbon dioxide react with the water that forms the carbonic acid. You can observe in case of the सबैभन्दा तलको चाहिँ रियाक्सनमा देख्न सकिन्छ. that carbon dioxide respiration बाट आएको अथवा एटमोस्फियर बाट आएको मेबी that carbon dioxide dissolve with the that water and that form the carbonic acid form गर्छ. and carbonic acid there is the hydrogen ion dissociation of hydrogen ion which forms that decrease the soil pH and decrease the. In case of the daytime, when there is a high amount of the biota, high amount of the summer aquatic weeds, there is the chance of the there is the chance of higher value of pH. And when the pH is higher, pH higher there is the chance of ammonia volatilization. Changes of the soil को concentration हामी हेरौँ त soil को चाहिँ in case of the pH अरु कुरालाई छोड्दियौ. बरु pH हेरौँ चाहिँ अरु कम्पोनेन्टहरु पनि छन् which is also responsible for formation of the pH को निम्ति चाहिँ जस्तो pH चाहिँ के हुने भन्दा 6 हैन टाइम अफ आवर छ नि त. 6 बजेको 10 बजेको 14 बजेको 18 बजेको र 22 बजे हैन. हामी एक्स एक्सिसमा देख्छौं. and there is the secondary y axis भनेको चाहिँ राइट साइडको y एक्सिसमा there is the pH as well. त्यहाँ चाहिँ pH पनि छ. त्यो बेलामा हेर्नु त के देखिन्छ भन्दा pH is increased during the daytime मा चाहिँ increase छ र night time मा चाहिँ decrease छ, which is responsible for the highest loss of nitrogen from the volatilization. What are the factors affecting the nitrogen volatilization or ammonia volatilization को factorहरु के हुन्छ? One is the moisture content. The rate of ammonia volatilization and water evaporation from the surface soil follows the different factors. हैन. अब हामीलाई के लाग्छ भन्दा फिल्डमा चाहिँ पानी हुन्छ, जति इभापोरेसन हुन्छ त्यति नै के हुने भयो ammonia volatilization हुन्छ जस्तो लाग्छ. But that doesn't occur because in case of the reaction, it is the first reaction to observe that ammonia when it is ammonia in case of the solution, that means that present in water must diffuse to the soil before the volatilization. यो ammonia जुन चाहिँ soil solution मा छ, त्यो soil solution मा भएको ammonia चाहिँ केमा जानु पर्दो रहेछ भन्दा soil मा जानु पर्दो रहेछ before volatilization. भनिसकेपछि यदि ammonium ion ammonium that is the ammonia छ solution को, it is the third one हैन. सबैभन्दा बीचमा भएको ammonium solution ammonia जुन solution मा छ, if that is directly released to atmosphere, त्यो चाहिँ डाइरेक्टली एटमोस्फियरमा रिलिज हुन्थ्यो भने त्यो बेलामा चाहिँ अमाउन्ट अफ इभापोरेसन सँग चाहिँ भोलाटाइलाइजेसन चाहिँ रिलेटेड हुन्थ्यो. But in case that there is a different function चाहिँ के छ भन्दा डिफरेन्ट छ, त्यही भएर soil moisture content doesn't matter. Another is the pH. Increase in the pH increases the ammonia volatilization. Ammonia volatilization increase हुन्छ. Ammonia volatilization process is the acidifying process. Alkaline soil buffer the H plus ion जति चाहिँ के हुन्छ भन्दाखेरि H plus ion ammonium ion बाट ammonia बन्दाखेरि that leads to H plus ion that is the ammonium ion that is the acidic ion. त्यो चाहिँ acidic ion हो जसले soilलाई चाहिँ acidic बनाइरहेको भनिसकेपछि के हुन्छ भन्दाखेरि जब soil चाहिँ alkaline छ भने that buffer that the acidic ion which is formed during the change of the ammonium ion to ammonia. Another is the cation exchange capacity. Cation exchange capacity that influence the degree of the ammonia volatilization. Higher the cation exchange capacity, there is the low ammonia volatilization. Why that happens? किन चाहिँ cation exchange capacity बढी हुने बेलामा volatilization low हुन्छ because there is a few amount of that absorbed ion that is soluble in the water. जति चाहिँ हाम्रो फर्स्ट रिएक्सन को टपमा भएको रिएक्सनमा पनि हामी फर्स्टमा के देखिरहेका छौं that absorb in soil मा absorb भएको ion that must release into the soil solution or release in the water मा चाहिँ रिलिज हुनुपर्छ. त्यो रिलिज हुने भनेको जुन soil मा cation exchange capacity कम छ त्यसको रिलिज चाहिँ हाई हुन्छ. जुन soil को cation exchange capacity बढी छ त्यो soil को चाहिँ absorb चाहिँ बढी हुन्छ र रिलिज चाहिँ soil solution मा कम हुन्छ. त्यही भएर cation exchange capacity बढी भएको soil मा there is the low ammonia volatilization. The peak ammonia volatilization occurs during the first and second day when the nitrogen content of the flooded soil is also the highest. हैन सबैभन्दा बढी चाहिँ जुन बेलामा हामी फर्टिलाइजर हाल्दिन्छौं फर्टिलाइजर हाल्दैपछि त त्यहाँ चाहिँ के हुने भयो भन्दाखेरि क्याटायनहरुको कन्टेन्ट बढ्ने भयो. एकदम धेरै क्याटायनहरु भयो भने त सबै क्याटायन त होल्ड गर्न सक्दैन सोइल पार्टिकल्सले. त्यो बेलामा फ्री ammonium release in the soil that moisture or the release in the soil solution of the water. That means there is a high chance of volatilization. In case of the denitrification कहिले हुन्थ्यो भन्दा 1-2 हप्तामा हुन्थ्यो भने volatilization चाहिँ के हुन्छ भन्दा सुरुको 1-2 दिनमा there is the highest volatilization. Another is the lime content. The ammonium fertilizer plus carbonate yield to the ammonium carbonate with the carbonic acid and the ammonia loss. हैन चाहिँ lime content बढी भयो भने त के हुने भयो ammonium that is react with the carbonate जुन चाहिँ calcium carbonate.
Oh no.